I just mentioned that in order for spontaneity to exist, it requires that delta G is a negative value, or that now that E0 has to be a positive value. I had written earlier that the solid copper can react to become copper 2 plus and 2 electrons. And I had mentioned that the E0 for this was equal to negative 0.34 volts. And because E0 is negative, this cannot be a spontaneous reaction. When I put it with another half reaction being the H plus from the HCl. So how is it that we were able to get copper solid to be aqueous copper in the copper penny reaction? If you recall, we put the copper penny into nitric acid, and so now I've got a different half reaction that I can use. Rather than just H plus going to H2, which has a zero potential, we can take a look at a reaction of nitric acid. And nitric acid, just to balance it out, if I put it in with some H plus and add an electron to that, I can get NO2 gas and H2O from that, and the potential for this is equal to 1.84 volts. All right, so I'm going to tie these two reactions together, but what you should recognize first and foremost is that I have different numbers of electrons. 2 electrons in the products, 1 electron in the reactants, and so I'm going to have to multiply this nitric acid equation by 2 in order to get this to work out. All right, and so now I have, when I add these two things together, I have copper plus 2 nitric acids plus 2 H plus, and I'm not going to put the 2 electrons in there because those will cancel out, and I kind of need my room here. And the products here are copper 2 plus and 2 NO2s and 2 waters. And the potential for this, when I add these two things together, is a value of 1.50 volts. You may have recognized that I multiplied that second equation by 2, but I did not multiply the nitric acid potential by 2. And the reason for that is because the potential is an intensive property. And what do I mean by that? It's an intensive property like temperature is an intensive property. Density is an intensive property. So if I've got a gallon of milk, the density of that milk is, say, 1.1 grams per mil. If I have 2 gallons of milk, the density is still 1.1 gallon or 1.1 grams per mil. Temperature, if I've got one container that's at 80 degrees and another temperature that's at 80 degrees, and I combine these two containers together, the temperature will be 80 degrees. It's not going to double because I have twice the amount of stuff. Likewise, when I have twice the amount of stuff here, I do not double that potential. All right? It is similar to having an energy diagram, right? And in this energy diagram, I might have copper and nitric acid up here, and then in the products down here, I have NO2 and copper 2 plus, and then I have to go through a bit of a hump in order to get down there to the products. But the difference in energy between these two things is 1.50 volts, right? I'm not going to double that because I have twice the amount of stuff there, right? So that's energy versus reaction progress or time or whatever you want to call that. I can convert that 1.50 volts into 290 kilojoules if I were to take a look at conversion of E into delta G. E, the potential, is independent of the number of electrons. So if I have 2 electrons or 4 electrons, the potential is still going to be the same amount. The delta G, on the other hand, is dependent on the number of electrons. It is dependent upon how much stuff we're using. So if I have 2 moles of something, I'm going to get twice the amount of energy out of it. But the system. When something else that we can use as an analogy to this, when you think of a AAA battery, right? If you have one of those at home, how many volts does a AAA battery have? A AAA battery, if you go and take a look, you're going to find that it has a potential of 1.5 volts. What about a AA battery, right? AA battery, 1.5 volts. What about a C battery? Any guesses? 1.5 volts. And a D battery, 1.5 volts. The reason for this is because we are using the same reaction in every one of these batteries. These batteries are all based on zinc and manganese oxide, manganese 4 oxide, combining together to give zinc 2 plus and Mn2O3, right? Every battery has that combination in there in order to get, well, I shouldn't say every battery, because we've got NiCad batteries, we've got or metal hydride batteries. So, but your typical dry cell is this particular reaction. So, why then do we need to have different kinds of batteries? You recognize, of course, that the D cell is a much bigger battery than a C cell, which is bigger than a AA, which is bigger than a AAA. The reason that we need different sizes of these batteries is because they all have different amperages associated with them. The AAA battery has an amperage of 1,000 milliamps. If you take a look at the AA battery, it has 2,000 milliamps. And the C battery is 4,000 milliamps. And if you were to take a guess about the D battery, you'd probably get it right, 8,000 milliamps, or 8 amps. So what is an amp? An amp measures how many electrons are moving per second. An amp is equal to 1 coulomb per second. It is a measure of number of electrons over time, right? It's kind of like if you were to think about water in the same sort of way, the flow of water as opposed to the flow of electrons. You might think of the D battery as being something like Niagara Falls. It's a fairly wide river that all of a sudden is plunging down. You get a lot of power. The pace of this river is very, very fast compared to, say, the DuPage River. The DuPage River carries a lot of water, but it moves much more slowly, and so you get a lower pressure on the DuPage River. If you think about the AA or the AAA, ideally those would again be the same size rivers, but each one would move more slowly. And so what about, say, a 9-volt battery? The 9-volt battery actually uses the same chemical equation that we've been using so far. And so you would expect it to be a 1.5-volt battery. But the thing is, we've stuck 6 of those things side by side by side by side by side by side. Right? So we've got 6 tiny batteries all connected in a series, which allows us to multiply that 1.5 volts by 6, which would give you 9 volts. But the amperage on a 9-volt battery is much smaller. The amperage is only 500 millivolts. So you don't get a lot of electrons moving, but you get them moving with a lot of power. And so that's the difference between a 9-volt battery and those other batteries.